Now let me return to the notebook. I think it's done. And if we look at our model, after 10 epochs, its accuracy has gone from 36% or almost 37% to 75% accuracy. Its loss is, well, not very good. It's not even 0. But we could have, in order to improve the loss function, we could increase the number of epochs. But even then, our data is problematic because it's very small and our neural network is quite simple. Anyway, the accuracy is not bad. So 75% of the time, we should, not 75% of the time, but 75% accuracy, we should get the picture that the model is looking at. So let's see how this happens. And then I'll return and talk about sigmoid and cross-entropy. Oh, but we only have 15 minutes left. Okay, so let me do this quickly. I am going to upload a picture from the CFAR 10 database. Okay. I will use Keras to load the image. So I'm going to go Keras. I'll leave this out for now, just for the sake of time. But basically, I was only going to plot the metrics. Actually, I think I have the code. I can just copy paste it. So let me copy paste it. Test images, test LPLS. And for the metrics, we want this to be I was supposed to assign to this a variable. To this mistake. No problem. I'll share this notebook with you and you can run it. But we need this in order to plot it. But I won't plot this right now. I'm just going to comment it out, and I'm just going to show you sample classification. So I'm going to load the image, sample image. And I will use the load image function from Keras to take this cat picture, which is from CFAR. This is PNG. And I need to specify its dimensions, which of course is 32 by 32. And then I need to convert it to an array and then normalize it. So I'm going to go sample image dot img2 array into a numpy array test or sample image. And then sample image equals sample image dot reshape. So we have one sample that is 32 by 32 with 3 color channels. And then we want to normalize. So this is normalize. So what do you mean by normalize? So we have 3 color channels. In each color channel, the brightest pixel. So for example, if it's the red channel, the most red pixel will have value 255. And the least red pixel would be 0. We want to normalize it because the machine learning model does not understand what these values are. And moreover, if you remember the slides that we looked at when I was talking about the matrix operation of neural networks, it will throw off our arithmetic. So to normalize it, what we do is we take the sample image, and since it's a numpy object, we can divide it by 255. So if a number is 255, if it's like in the red channel, it's perfectly red, it will be 1. Otherwise, it will be 0. So I will now run this. And this is supposed to be target size. Okay, so if I show you what the sample image is, you will see it's a it's a tensor basically. And all of that, this is what we mean by normalized. So this is 77% of the pixel brightness. Okay, then what I'm going to do is I'm going to use the predict method. So I'm going to go predicted class index will be equal to model dot predict. Okay, you see we have a distribution, which means this is the shape that the model has predicted. So remember, we said that in machine learning, everything, whether it's a property or a picture or a soundbite, will be associated with the shape. This is the shape of the data. Now, what I need to do is use the right code. Now, to understand what this is, we need to talk about the sigmoid, or I keep saying sigmoid. Here we use the softmax function. We need to talk about softmax, and then we will talk about the cross-entropy.